Okay, in this problem we need to use the definition of the derivative to find f prime of x, that is the derivative of f at x, if the original function f of x is this guy right here. Of course, if we're going to use the definition of the derivative, we should probably remind ourselves of what that says. And notice right here, f prime of x, the derivative of f with respect to x, is defined to be this limit, provided it exists. So, let's see if we can't set up this limit for this function. Let's move this down here a little bit out of the way. Now, we need to start off with a limit as h goes to 0. And it's of some fraction here. The numerator here has two pieces, f of x plus h. Now, how do I find f of x plus h? How do you find f of anything? You take that thing, that input, and you plug it in for each occurrence of your input variable here. So this should be 1 over 2 minus 3 times the quantity x plus h, where that guy right there is your input. Okay, so I'm going to put that here on the left side of my numerator. Okay, so that piece right there is that piece right there. Now I need to subtract off f of x. Well, we know what f of x is. It's sitting right here. So let's go ahead and put that in. And then, of course, all of this is sitting over in h. So let's go ahead and write that in as well. Now, notice, whenever you're using the definition of the derivative, we will never be able to immediately rewrite this limit of a quotient as a quotient of limits, because the denominator, as h goes to 0, always goes to 0. It's h. So we'll have to find another way to evaluate this limit. We hope, I suppose, that this factor of h that is going to 0, that's causing a problem for us, will go away. We'll cancel off somehow with the numerator. That may not always happen, but we can hope for that. So, turning our attention to this particular limit, if we are trying to cancel off this h with something above, we have to admit that our expression is kind of a mess right now. In order to be able to cancel off a common factor, we need to have everything in completely factored form. And further, our numerator is not only not in completely factored form, it has fractions in it. This is a complex fraction. We need to simplify things before we proceed too much further. Of course, one thing you could do to simplify the numerator is to combine these two fractions. Actually do the subtraction. Of course, that requires common denominators. So let's go ahead and construct those. First, let's rewrite things here, giving ourselves some spaces here for the extra factors we'll need. Now, looking at this first denominator of these two, notice it has this large factor, but it is missing this small one. So let's go ahead and throw that in the bottom. Of course, I can't just multiply the denominator there by 2 minus 3x without changing the overall expression, but if I put 2 minus 3x in the numerator as well, notice I'm really multiplying here by a carefully chosen value of 1, which won't affect the overall expression. Then doing the same thing to this denominator, asking ourselves the question, what factor is it missing? Well, it has this one, but it doesn't have this one. So let's go ahead and throw in that larger factor on the bottom, and again, so that we're really just multiplying by a well-chosen value of 1, let's throw it in on the top as well. Now, let's see what this produces. Let's get this out of the way, because I think we're going to need the space. Notice both denominators now are alike, so I can simply combine these two fractions here, these two products of fractions, into a single large fraction, like so. And further, once you have it into this form, once you have it into some single fraction over some other value, recall this is the same as a over b divided by c, or equivalently multiplied by its reciprocal, which is just a over bc, the net effect is when you see a fraction like this, you can take this larger denominator here and just shove it into this smaller denominator to get that product there. So here, what's playing the role of c is h, so I can simply take this h and plug it up here. So I'm going to do that to keep things a little bit cleaner. Now looking up top, we can simplify this, right? We've got a 2 minus a 2. Those things are going to cancel off. And further, distributing this negative out, we see we have negative 3x minus a negative 3 times x, that's plus 3x, and minus a negative 3 times h, that's plus 3h, still over this large denominator here. I'm going to go ahead and distribute this 3 as well. So that's 3x minus 3h, and times 2 minus 3x over here. Notice the negative 3x and the 3x also cancel off. And this is great because look at what happened here in the numerator. We have a single expression, a single term. One of the factors of that is h. Down here in the denominator, we also have a factor of h. Those h's now cancel where they did not before. And with the h in the denominator gone, now as h goes to 0, notice our denominator does not go to 0. So we are free to evaluate this limit of a quotient as a quotient of limits. And of course the top, all that's left here is a 3. And the bottom, as h goes to 0, notice this little term here goes to 0, leaving 2 minus 3x, and another 2 minus 3x multiplied by it, so that brings that up to a square, and we are done. That is the value of the limit as h goes to 0, and hence that is f prime of x. We're done.